Assalamu alaikum warahmatullahi wabarakatuh. We have lesson 9 in chapter 4, isosceles and equilateral triangles. If I ask you find each angle measure in this triangle, you know that this equilateral triangle, each angle measure is 60. Is true or false? Every equilateral triangle is isosceles? The answer is yes, true. Every isosceles triangle is equilateral? The answer is false, because an isosceles triangle can have only two congruent sides. So not all isosceles triangles are equilateral. By the end of this lesson, we can prove theorems about isosceles and equilateral triangles, apply properties of isosceles and equilateral triangles. We have legs of an isosceles triangle, vertex angle, base angles. If you look to this isosceles triangle, so angle number 3 is called the vertex angle, which is the angle included between the two congruent sides. And angle 1 and 2 are called the base angles. And this side is called the base. We have two theorems that isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite the sides are congruent. If you look here, if we have in this triangle two sides are congruent in a triangle, so where is the angle opposite to the side AC? Yes, it's angle B. And where is the angle opposite to the side AB, which is angle C? So if the two sides are congruent, so the two opposite angles are also congruent. And the converse of the isosceles triangle theorem, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if we have here angle E is congruent to angle F, so the side opposite to angle E, which is DF, is congruent to the side opposite to angle F, which is DE. Okay? The isosceles triangle theorem is sometimes states as base angles of an isosceles triangle are congruent. We can state this theorem as base angles of an isosceles triangle are congruent. Let's see example 1. The length of XY is 20 feet. Explain why the length of YZ is the same. If you look here to this figure, you know that measure angle X is 40. What about measure angle Z? We know that the exterior angle of the angle Z 140. So by the linear pair, we know that the angle adjacent to 140 is 40. So in the triangle XYZ, in the triangle XYZ, if this angle is 140, so its linear pair is 180 minus 140, which is 40. So in the triangle XYZ, we have angle 40 and another angle 40. So by the converse of the isosceles triangle theorem, you know that the side XY must be congruent to the side YZ. Now, if the distance from the Earth to a star in September is 4.2 times 10 power 13 kilometers, what is the distance from Earth to the star in March? And explain. We know that the distance will be the same since there are 6 months between September and March, and the angle measures will be approximately the same between Earth and the star by the converse of the isosceles triangle theorem. The triangles created are isosceles and the distance is the same. This is checked out. Okay, let's see example 2. Find measure angle F. We have here isosceles triangle because the side DE is congruent to the side FE. So the opposite angles or the base angles of the isosceles triangle are congruent. And we know that the sum of measures of angles of any triangle is 180. So if we represent measure angle F and measure angle D as x degrees, so measure angle F plus measure angle D plus measure angle E equals 180, the triangle sum theorem. So x plus 22, we substitute by the given values, equals 180. So now you can solve this equation algebraically, x and x, 2x, and subtract 22 from both sides. So 2x equals 158. By dividing both sides by 2, so x equals 79 degrees. So measure angle D equals measure angle F equals 79. Also, you can solve this question in one step. If you want to find the base angle of isosceles triangle, so you can write it in one step. How? You can write 180 minus the vertex angle 22 all over 2. Again, 180 minus the vertex angle 22 all over 2. It will be 79. Now in this question, we want to find measure angle G. We have here isosceles triangle. So the two base angles are congruent. So I can write that measure angle G equals measure angle J. By substitute, x plus 44 is equal to 3x. Solve this equation algebraically, subtracting x from both sides, so 2x equals 44. Now divide both sides by 2, so x equals 22. To find measure angle G, substitute by the value of x as 22, so measure angle G equals 22 plus 44, which is 66 degrees. Now, check it out. Stop the video and try to solve alone. Now, check your answer. And we said we can solve this question only in one step if you write 180 minus the vertex angle 48 over all over 2. Second one, try by yourself. Check your answer now. Don't forget to find the measure of the angle because I don't ask you about the value of y only. I ask you about measure of angle n. Now the following corollary and its converse show the connection between equilateral triangles and equiangular triangles. if a triangle is equilateral, then it's equiangular. Equiangular means the three angles are congruent and the measure of each is 60. If a triangle is equiangular, then it's equilateral. So it's the same. If the triangle is equiangular, so it's equilateral. Let's see example 3. Find the value of x. Maybe if you don't look carefully to this diagram, you said that how can I find the value of x? I know only measure of one angle. But if you look carefully at this diagram, you can see that this triangle is equilateral triangle. And we know that the equilateral triangle is equiangular. It means measure angle K is equal to measure angle L is equal to measure angle L. K equal to L equals to M. And each angle is equal to 60 degrees. So you can write now 2x plus 32 equals 60 degrees. Now solve as algebra by subtracting 32 from both sides. So 2x equals 60 minus 32 equals 28. Then divide both by 2. So the value of x is 14. In this question, I ask you only about the value of x. So this is the last step. Now find the value of y. Also, this triangle is equiangular. So any equiangular triangle is equilateral. It means the side NO is congruent to the side OP. Also is congruent to the side NP. So the length of the side NO is equal to the length of the side OP. So you can write that 5y minus 6 is equal to 4y plus 12. Now solve this equation algebraically. You can subtract 4y from both sides and add 6 to both sides. Again, subtract the least variable, subtract 4y from both, and then add 6 to both sides to make y alone. So y alone equals 12 plus 6, which is 18. Check it out, 3. Now check your answer. Remember, a coordinate proof may be easier if you place one side of the triangle along the x-axis and locate a vertex at the origin or the y-axis. Let's see in example 4. Prove that the segment joining the midpoints of two sides of an isosceles triangle is half the base. Given in the isosceles triangle ABC, let x is the midpoint of the side AB and y is the midpoint of the side AC. So we want to prove that xy, okay, equals half AC. The length of xy is half the length of AC. Let's draw a diagram and place the coordinates as shown. Because the triangle is isosceles, we make the position of the triangle that one vertex of the base is the origin and the other one is 4a and 0. So The vertex angle is 2A and 2B. Now, by the midpoint formula, the coordinates of x are A and B, and the coordinates of y are 2A plus 4A is 6A divided 2, it will be 3A. 2B plus 0 over 2 will be only B, like this. By the distance formula, xy, you can substitute by x and y coordinates, so it will be root 4a power 2. Root 4 is 2 and root a power 2 is a. And AC, the length of AC is 4a. So the length of xy is half the length of AC. Now check it out for. Check your answer now. We have now lesson quiz. You can solve it and send it to me. Goodbye. See you another time. Thank you and goodbye.